No, it's just. Did you just get this one?
I have to. No. Okay. So number 65 was a question. So this is a great review of algebra. Plus, it also shows how we're going to apply multiple perspectives to a problem. So it says find the points of intersection, and we're given those two things. What does that mean? Raise your hand. What does this mean? Yeah.
You find out where x is 0 and y is 0, and then solve for everything else.
Where x is 0 and y is 0, and you solve for everything else.
So like, you can cancel out x's and then solve for the substitution.
Intercepts. If you set x equals 0,
Yeah. And you can find y.
then you get the y answer. Doesn't that give you?
Then you can plug it in and find that.
Okay, I got to make sure we're here. X-axis, y-axis. If I let x equal 0, because all this is a big number line, right? If I let x equal 0, then what I'm going to be finding is the location where the y is equal to some number. And that's known as a y-intercept. Okay? Maybe it's just how you're saying it.
Yeah, I mean, I got the right answer.
Okay. Okay, yeah.
Aren't you trying to find where, like, you have two lines going and you're trying to figure out where those two lines meet?
Okay, so like in this thing here, this could be like one of the graphs, and then this could be another graph.
So you're trying to figure out, like, that point right there. Yeah.
And then that looks to me like a point of intersection. Okay? And so what it is, it's an x-coordinate and it's a y-coordinate. Okay? So it's an x and a y-coordinate that is a point of intersection. Okay? So, but I'm confused. That's two algebra things. This is a picture. Yes? Yeah. Tell me anything you want to tell me. Tell me your life story.
What I did was I solved for y for each of them.
Solved for y, okay,
And
for
then
each of
I
them.
Set them equal to each
Set them equal to each other. Okay, and then what did that do?
And then you can like factor it all and then you know,
Then you get your answer. You get an x answer. And then what does that x answer mean?
then you can like plug it in back into the formula so then you can get your y answer and then you get the
Okay. That works. Why does it work? We'll get to...
You want to find an x and y that work in both cases.
Okay, that's the magic answer here. Big picture on this whole thing, to find the intersections, you're finding the x and the y that are the same x and the y that work in both equations. Like if I plug a 1 in here, and I plug a 2 in here, 1 squared plus 2 squared is 5. That works for the first one. Does it work for the second one? 1 minus 2 is not 1. So the point 1 comma 2 is not a correct point. Okay? So shoot, we got to try another one. Okay? So we could guess and check and get our answers that way, right? Okay, or we could use a technique like that, solve them both for y and then set them equal and then solve for x. Then we got it. Okay? Is there another way that we can approach this? Yeah, Bitsy.
Where I first made the graph, like I graphed it, and then I made like a few chart and found like points that like I kind of like was like, oh, it looked like about here, so I tried different points.
Okay,
Kind of guessing.
so you turn both of those into a picture. Okay, what is that first thing? The top one. So I'm going to draw a big thing here. You guys covered this last year. I know you did. X squared plus y squared equals 5. Well, let's start easy. What is this thing? This is a line, okay? This is known as a linear equation. Okay, it's a linear equation. X and Y both have a power of 1. Okay, so that's going to be a line every single time. You make a t-table of that, bam, a line. Okay, but then all of a sudden if you start putting squares in here for x's or y's or whatever, you start to get different shapes. Okay, if you have an x squared and you have a y squared, they're added together and they equal some number. That's actually a pattern for some type of thing. Who remembers exactly what it is? It's a circle. Okay, so this is a circle. In fact, last year you would have learned this equation: x squared plus y squared is equal to r squared, which is a circle centered at the origin with a radius of r. Then when you learn conic sections, you learn this: x minus h quantity squared plus y minus k quantity squared is equal to r squared. Remember that one? This is a circle centered at h comma k, that coordinates, the x and the y, and it still has a radius of r. Okay? Then in fact you could multiply this whole thing out and you would get something that would look like this. It'd be like a ax squared plus a by squared plus a c x plus a dy plus an e is equal to 0. That's what you get if you multiply the whole thing out and you get it. It's this big polynomial type thing. Okay, this is still a circle, which is off the radius. It can be anywhere that it wants to be, but the h and the k, the center of it, are buried within the a's, the b's, the c's, and the d's. Okay, so what we have here is a circle and a line, and so I want to know, first of all, how many different possible answers can there be? 2 answers? Is that the only option? One answer? No answers? Or is that an answer of 0?
You could have a line and then a circle right here. That messes it.
Okay. So if I drew a circle and a line, that's one possible case, and I would have 2 answers. Right? Could have another one, and if it just touches it at one spot. Did you know that it can touch it just at one spot? Okay. What do we say when a line and a circle meet like that? Yeah. This is the tangent line. And if you study physics, tangent lines are a big deal. Okay. And then the last possibility is if the line misses it. Okay? So here's what we're going to have. We're going to either have 2 answers, 1 answer, or no answers for this possible thing. Okay? So let's graph it first and see what we get. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And let's plot this. So x squared plus y squared is equal to 5, which means that the radius is the square root of 5, which is about how much? 2.2? Okay, we'll say it's in there. So I'm going to go here. Remember, if I make the dot big enough, then it's cover all the possible. So there's the circle. Okay. And then we have this thing. And now I could make a t-table for this, but you guys learned some shortcuts on lines. What can I do with this to help graph it better? Solve it for y. So if I take this puppy and I solve it for y, I'm going to throw the y on this side, or subtract the 1, put it over here. I get y equals x minus 1. Okay, what does this, we know some stuff about this. What do we know about a line that's y equals x minus 1? -1. So you learned this thing, y equals mx plus b, right? So b is -1. That's the y-intercept. That's where it crosses the y-axis. So -1 The line goes through there. That's the coordinate 0, -1. And if I plug a 0 in for x and a y in for -1, I get an answer of 1, so it all matches up. Okay? All right, what's the other thing that's missing? Slope. And what's the slope? 1. Because that's the number that's here. So the slope is 1. So if I'm up from this point, I can go up 1 over 1, up 1 over 1, and then I can even go down 1 over 1. And these are 4 of the infinite number of dots. Just pretend it went through there. Let's make the dot really big. Then, so door number 1, door number 2, door number 3. We have door number 1. We've got this scenario. So it appears as though it's going to be 2, 1, and -1, 2. Okay? We could plug them in and test it, but I'd like to just do an algebraic proof just to verify that that actually is what it is. But instead of solving it for y, what I'm going to do is I'm going to solve one of these for y, or I think I'm going to solve this one for y and then plug it into the other one. So see the x minus, well, I actually have it right here. I'm going to take this, y equals x minus 1, and I'm going to plug it in. So now I've taken the second equation, which is y equals x minus 1, and I plugged it in for the y here. Look familiar? Now I just got to work out the math, and we'll get some x's. So x squared plus, this is a binomial squared. You should know this. Anytime you have a plus b quantity squared or a minus b quantity squared, you should know what those two are. Remember what those are? This is a squared plus 2ab plus b squared. That's if you just multiply them together. And here, this is a squared minus 2ab plus b squared. Those are the general formulas for it. Okay, so if I follow that formula, I can say this is x squared minus 2x plus 1 is equal to 5. Remember, you have to check my math because I'm not always going to be right, purpose or not. Okay, so here we go. 2x squared minus 2x minus 4 is equal to 0. I just subtracted the 5 from both sides. Oh yeah, I love this part. You can just cancel those 2's. Can I cancel the 2's? Okay, the secret is to factor out the 2. I could factor it as it is, but watch this. When I say, oh, 2 goes into each one of those, I can divide everything by 2. What I'm really doing is this. I'm saying, oh, I'm going to factor out a 2. Okay? And then what I'm really doing is dividing both sides by 2. And that's why this cancels. So it's the same exact thing as x squared minus x minus 2 is equal to 0. That's why it's the same exact thing. We're actually factoring and then dividing. That's why we can get that. All right, trinomial. You guys did a bunch of this previous years. A little factoring, 1, 2, negative, positive. Look familiar? And then from this, you just say x is equal to -1 and +2. How come you can say that? Set them equal to 0. Good, because what's really going on here, we're using probably the most underrated algebraic formula of all time. And it's the zero product property. Zero product property. This guy, I think he gets just no love. It says if a times b is equal to 0, then right. Then either a is equal to 0 or b is equal to 0. That's the only way that that works. So what we have here is this thing times this thing is equal to 0. So the only way that we can we can figure this out by saying, well, wait a second. Either x plus 1 is equal to 0 or x minus 2 is equal to 0. And so we can get two answers. Oops. We can get two answers, positive 1 and negative 2. Oops. Negative 1 and positive 2. One of those things. And that's how we can get our two x's. Does that make sense? Okay. Review of algebra, zero product property. Now, what's going on here? This means that when x is equal to negative 1 and when x is equal to 2, that's where the two solutions are. So if I take negative 1, plug it back into x, what do I get for y? What do I get? Yellow. Negative 2. Plug it right in here. Negative 1 minus 1 is negative 2. Okay. Plug in 2 for x. What do you get? You get 1. What does this mean? Okay, that's the big idea. Look at this. This is an ordered pair, negative 1 comma negative 2, and this is 2 comma 1. These are the 2 points of intersection of those two graphs. And where are they? This one is right here, and this one is right there. You see that? Now, you can see I took a lot of time to go through this, okay? But the point that I'm always trying to convey is you can solve any problem as long as you just start chewing on it, analyze it, take a look at what do I got here? How can I solve it? Do I know what, if I look at it from another way, what can I see? That's the whole point. Okay? They take longer to do that way, but guess what? You'll be able to solve any problem because you're doing it that way. Have you ever done a homework assignment where you're like, you'll read the problem and they're like, the teacher never did one of these? Never happened before? I don't know how to do this one. Teacher never did one of those. Okay? You're going to get that a lot here. Okay? You're going to have to think because we're using the whole concepts. Okay? Because on the AP test, trust me, you're going to see a lot of questions for which you've never seen one like that before. And you have to be able to think while you're taking the test. So that is the deal. Okay. Well, let's move on. I want to take a look at the trig functions today. We looked at the natural log yesterday. So I'd like to start off with y is equal to the sine of x. And I want to analyze it. What is going on here? I want to be able to graph the sine function without a calculator. Okay. Okay. The sine of x. What is it? What does it mean? Does anybody have a definition of what the sine function is? Because we can base everything off of a foundational thing like a definition. Look it up. Somebody look it up. Tell me what the sine is. Somebody beat Megan today. Oh, he's got a head start. Yes. Opposite. I'm hearing opposite over hypotenuse in a triangle. Any kind of triangle? Right triangle. Have you ever heard that the definition of the sine of a number is equal to the opposite over the hypotenuse on the right triangle? Have you ever heard that?
No, I got the definition.
Okay, what do you got?
Sine in mathematics is a trigonometric function of the angle. The sine of an angle is defined in the context of the right angle. For the specific angle, it is the ratio side that is opposite that the angle to the length of the longest side of the triangle, i.e. the hypotenuse.
I.e. the hypotenuse.
Alright, I like the other one better.
Google.
Okay, so here's what it's saying. So let's draw a right triangle. Okay. And to make this a little bit better so it's not as confusing, I'm going to turn this into theta. Okay, it's a Greek letter that we often use for angles. So I'm going to place theta here, and it's the number of degrees of that angle. Okay? And so it turns out that for every single angle, that if you have the side that is opposite it, which is here, and you have the hypotenuse, that the sine of the angle is equal to the opposite over the hypotenuse. Okay? The so in the SOHCAHTOA. Okay? Now, what's really cool about this is this, watch. So that means this angle, or this side and this side. You say, yeah, but what if I make a smaller triangle? Okay, so if I make a smaller triangle, so here's a triangle. It still has to be a right triangle. Here, okay. Opposite and hypotenuse, right? It turns out that this one is smaller and this one's smaller than the other one, but when you divide this one by this one, you get the same exact answer all the time for a specific angle. Okay? That's the deal with this. And it doesn't matter how big you make these things. If you make it a right triangle, it works every single time. And that's how they define the relationship between the angle measure here and this made-up thing called the sine.
So if they have the same angle, it'll always have the same ratio.
Exactly. Every single time. Okay? Now, so how does this turn into a wavy graph? That's what I want to know. Right? Because that's the real trick. How does this definition make us have a graph that goes like this? Yeah. The unit circle. That might be why I gave that to you today. Yes?
You're graphing the y-axis of the unit circle as you're going around the gradients of these.
Okay. All right. We're on to something here. Okay. You have a unit circle in front of you. So let's take a look at a circle. Okay. Okay. So we'll start off with a circle. And let's study this circle a little bit, okay? So I'm going to slap this circle on the coordinate plane, and we're going to make it xy, okay? And just for the fun of it, we're going to make the radius of this thing equal to 1 unit, okay? 1 unit. That way it can be 1 foot, 1 meter, 1 light year. It can be anything you want it to be. Okay? So this radius is 1. Okay? That's the deal. Okay, so if this is true, then that means we have points we can start to plot. Right? So this point right here has coordinates 1, 0. Okay, so you can start to fill in your unit circle. This one is 0, 1. This one's negative 1, 0. And this one's 0, negative 1. And that's just easy because we know that the radius is 1. Okay? So what does this circle have to do with this triangle. I know it's got like pi over 2's and stuff like that in it, but what is that? Okay, the triangle will fit anywhere inside the circle. Very good. Watch this. So I'm going to make a triangle. A right triangle inside the circle. Okay? Triangle inside the circle. And the deal is, this point right here has to touch. Okay? Has to touch the circle. Okay? Now, just for any random point, this would be the x distance on the circle. Okay? This would be the y distance on the circle, up and down. And what's the hypotenuse? It's 1. It's always a radius of 1. Okay? It's going around all the time. So this is 1. Okay? So, okay, sine function. If I slap my little theta in here, okay, what would the sine of theta be? It'd be opposite over hypotenuse, which would be y over 1, okay? Which is y. Cosine. Cosine is adjacent over hypotenuse, and that means that it's equal to the x. So what this means is that for every single coordinate on the unit circle, every point that's on the circle, the x and the y coordinate are actually the cosine of the angle and the sine of the angle. Okay? Let's clarify this a little bit. Let's pick out some points and see what's going on. This point here, which is x comma y, is the same as the cosine of theta and the sine of theta. Those are the coordinates. Okay, so pull out your calculator, put it in degree mode, make sure it's in degree mode. And now I'm going to give you some numbers, and I'm going to ask you to think about what the answer is first, make a guess, and then test it by finding out what it is. Okay? So, watch this. Are you in degree mode? Got to be in degree mode here. Okay, so if I ask you, do not type this in a calculator yet. What is the sine of 0 degrees? The sine of 0 degrees means if this theta was 0 degrees, this thing would be all the way flat. And it's the y-coordinate here. Find the sine of 0. Did you get 0? Okay, what's the cosine of 0? 1. Can you tell me, by looking at the unit circle, can you tell me that the cosine is 1? Okay, yes, because it's this value right here. Okay, let's do another one. How about the sine of 90 degrees? When we're perfectly at 90 degrees, this theta comes all the way up here. It's the y-coordinate. So it should be 1. Go test it out. Did it work? What's the cosine of 90? 0. Okay? Okay, now a fun one. What is the sine of 30 degrees? No calculator. I'm going to get a little help here. Right here. Right here. Okay. This is a 30, 60, 90 degree right triangle, right? The y-coordinate is right here. How high is it up on the unit circle? It's actually exactly halfway. Okay? So that's why it's 0.5 for the sine of 30 degrees. Okay? Without a calculator, what is the sine of 97.4 degrees? Without a calculator, what is the sine of 97.4 degrees? It's an estimate. Everybody think of an answer. Okay, need an answer? What do you got? 0.95? Okay, keep thinking on that one. 97.4. 97 is about, I don't know, it's around here somewhere, right? Okay, what is the y-coordinate? Well, the y-coordinate's pretty doggone close to that 1, right? So the answer better be 0.9 something. Punch it in, what do you get? .9916. Okay, we were really, really close to the top there. Okay, so what I'm telling you here is, you can find the sine or the cosine of any angle with a pretty good accurate estimation by doing this. Okay, another one. How about the cosine of 308 degrees? And if we're within 1/10, I consider that pretty good. Okay, where's 308? You start here, right? You go all the way around. This is 270. And then we go past that, 38 degrees. 38 degrees, a little bit more than that. About right here. I don't know, just approximate it right about here. I go across here. What would you guess? Oh, sorry. Cosine, forget this. I'm going to go up. What do you get? I'd say about 0.6. Compute it. What do you get? 0.6 something? Okay. So this is common sense thinking about all of this. All right, people asked about when the next assignment is due. I want you to shoot for Friday to get that next page done. Whatever that next page is, I don't know what that page is.
I think you have to go up there and